Hello friends, in this video we will focus on basics of graphs and some important graph terminology. Graph is one of the dreaded interview topic, but once you become familiar with some of its concepts, you will start gaining the confidence to tackle graph related problems. Graphs in simple words is nothing but a collection of nodes and connections, or you can also say a collection of vertices and edges. So we can have different types of graphs. We can have graphs with direction. These are called as directed graphs. We can have graphs without direction, called as undirected graphs. We can have graphs with weights, called as weighted graphs. We can have graphs without weights, called as unweighted graphs. So if you look in this diagram, we have two nodes, 0 and 1, and there is a directed edge connecting these two nodes. So we have a directed edge from node 0 to node 1. So this is a directed graph. What it means is direction is important here. You can go from node 0 to node 1, but you cannot go from node 1 to node 0. This is a directed graph. The second one is undirected graph or an undirected edge. In here, you can say that node 0 and node 1 are connected via an edge, but there is no direction. That means you can go from node 0 to node 1, and also you can go from node 1 to node 0. So this diagram tells us that there are 7 edges or 7 nodes, 0, 1, 2, 3, 4, 5, 6. But this is an unconnected graph. Why? Because from node 0 we cannot go to node 3, 4, 5 or 6, and similarly from node 1 we cannot go to this portion of the graph. So this is an undirected, unconnected graph because there is no direction. This image of graph, this is called as a complete graph. Why? Because each node is connected to every other node. Then let's look at weighted graphs. What happens in weighted graph is you can go from one node to another node. In this example, you can go from node A to node C with a weight of 3. So there is some cost associated with going from node A to node C, and that cost is 3. Similarly, you can go from node A to node D. Again, the associated cost is 3. So graphs with relatively few edges are called as sparse graphs. Graphs with many edges and only few missing edges is called a dense graphs. Directed graphs are sometimes called networks. Now let's look at some of the applications of graphs. Representing relationship between components in electronic circuits. If we want to represent a transportation network like a highway network or a flight network, we can use a graph. We can also use graphs to represent computer networks like a local area network or internet or web. We can also use a graph to represent databases like relationship between databases, or if one table is connected to another table, we can show that using graphs. Now there are two basic ways to represent a graph. We can either use adjacency list, and this is the most popular representation or implementation for graphs, and this implementation is mostly used for sparse graphs. Then the second type is adjacency matrix. This we use adjacency matrix mostly when the graph is a dense graph. So there are some important graph algorithms one should know to be able to be comfortable uh, for graph related problems. The very first one is a breadth first search, or BFS. So if we want to traverse a graph, we can use a BFS. BFS is used to traverse all paths in a graph. BFS guarantees that it can find us the shortest path in unweighted graphs if we want to uh, travel from node A to node B. So usually BFS is helpful in uh, problems like finding minimum distances if we want to check if A is connected to B and traversing different paths in a graph. The second algorithm which we have to know is depth first search, also called as DFS. So similar to BFS, DFS helps us to traverse all paths in a graph. DFS does not guarantee the shortest path between two nodes, but it will tell us if a path exists or not between those two nodes. Then third is a topological sort. One of the implementation of topological sort can be done using Can's algorithm. And topological sort only works for directed acyclic graphs, also called as DAGs. And topological sort is useful for scheduling and ordering problems. At least one node needs to have an in degree of 0. What that means is the number of edges coming to a particular node should be 0. Then the fourth one is Dijkstra's. So Dijkstra's algorithm is a very popular algorithm to find shortest path from a single source node to all other nodes in a weighted graph, meaning weights associated for traversing from node A to node B. One of the shortcomings of Dijkstra's is that the weights cannot be negative. So Dijkstra's can be implemented using priority queues or without using priority queues. And there is a difference in the complexity, as you can see here. If you use priority queues, then it is a little bit faster compared to not using priority queues. So in the Dijkstra's, the shortcoming is that we cannot have negative weights. What if, we need to find the shortest path with negative weights? Then in that case, you can use the Bellman-Ford algorithm for the negative weights. If you're running short of time, and if you don't have to do both these algorithms, I would strongly suggest you should know Dijkstra's at least. Then the one of the other algorithm one needs to know is minimum spanning tree. So the basic concept of minimum spanning tree is if we have a graph with weights and all, it has all the edges, a complete graph, then a minimum spanning tree will basically it will have a v minus 1 edges of minimum weights. So there are two algorithms useful in finding minimum spanning tree. One is the prims and the other one is Kruskal's. So again, if you're short of time, you should know at least one of the algorithm to find the minimum spanning tree, either prims or Kruskal's if you're short of time. Just to review what we learned in this video, some of the basic concepts is we use BFS to find the shortest path in unweighted graphs. We use Dijkstra's to find shortest path in weighted graphs without negative weights. Bellman-Ford is used to find shortest path in a graph with negative weights. BFS is used to find the shortest path and not the DFS. Both BFS and DFS are used to explore all paths and vertices in a graph. Thanks for watching.